Hello and welcome back. This is Barrett from Cypress College, and in this video today we're going to cover the AWS Academy Lab on elastic load balancing and auto scaling. So we're going to be taking a look at ELBs, elastic load balancers, which automatically distributes incoming application traffic across different EC2 instances. So you'll see that we already have a web server instance created. We're going to create an AMI, an Amazon Machine Image from that. We're going to create a load balancer. We'll create a launch configuration and add an auto scaling group. So that way we can set alerts so that whenever, let's say, CPU usage hits a certain threshold, then new instances are going to be spun up and automatically placed in that auto scaling group. So the lab documentation is pretty straightforward, although I will say if you're a student following along with this, there is slight differences in task 2. So you may want to pay close attention when we walk through it. I have a feeling that AWS kind of changed some user interface options since this lab was created, but it's nothing too crazy or too difficult. So we'll go through that as we get there. All right, so let me go ahead and pull this over to my other screen, and you can see I am logged into the management console here. So for task 1, we want to create an AMI for auto scaling. So to do this, we're going to want to go to the EC2 service. You can get to it either by the search or recently visited. And you notice here, like we were talking about before, we already have a web server created. So this is what we're going to take an AMI image, or Amazon Machine Image and AMI. We're going to create one from this. So we go ahead and select that, come up to Actions, and then Image and Templates, create an image. So it's pretty straightforward. We're going to go ahead and name this web server AMI. And we'll give it a description, lab AMI for web server. And everything else here looks like we're going to keep this all default. You could always add a tag as well. Just remember, general best practice is to follow tagging requirements by your organization. Okay, we'll go ahead and create that image. And you can see here, successfully created this AMI. And if you wanted to look and see where that stores it, over on the left side here under images, you see AMIs. And now you will see that is actually pending because it's currently being created. Cool. All right, so that takes care of task 1. Pretty straightforward. Now, task 2, we're going to create a load balancer. And so we're still in the EC2 service. If we scroll down a bit on the left side, we see load balancers. Now, I mentioned in the beginning of this video that we need to do slightly different process than what's described in the AWS Academy task, most likely because Amazon may have changed some UI functionality around this part, but I'll go ahead and walk you through that. So we'll go ahead and create load balancer. And you see we have the various options. In this case, we're dealing with a web application, so we want to select an application load balancer. So we'll go ahead and press create. We'll give it a name of lab ELB. Now, this is going to be internet facing. And general best practice, if you think about it, we have that EC2 instance that is running the web server. Now, this we want to be private. We want this to be sitting in a private subnet along with whatever EC2s get added during our auto scaling, because you generally don't want somebody to be able to directly hit your server. Now, back in the day, before elastic load balancers were more widely used, it was pretty common that you would have that web server in a public subnet, because how else are people going to connect to it, right? But now that we have this new elastic load balancer technology, we're able to place only the load balancer in the public subnet, and then that can send that traffic to the private subnet where the web servers lie. So we'll leave this on internet facing. Now, very important, we want to make sure we select our lab VPC. And then we're going to map this to both of these availability zones. And we want to make sure that we choose public subnet for both of these. Okay, now for security group, and this is kind of where, if you notice in the lab documents, it would be telling you click next. So I think what happened is Amazon just decided to put this all together in all the same settings. But most important thing here, we want to select the web security group that is already pre-created, and we could exit out of the default security group here. And now this is where it gets a little bit different than the lab documentation. We need to create a target group. And then, because if we don't have a target group and you try to create the load balancer, you will see that it actually doesn't allow you to do that. So let's go ahead and click this here. It's going to open up in a new tab. And we will want to leave this on instances here. So this is related to the actual EC2 instances. We'll give it a target group name of lab group. Just make sure that the lab VP is selected. So it looks like it shows that by default. And you can see here it's going to be doing health checks via HTTP. So we'll go ahead and leave everything else as default. Go ahead and select next. And so you could see these are the two targets that it currently found here that we have already created. And we're going to go ahead and create that target group. Okay, so now that we have that group created, and once again, you just want to make sure that that was created in the lab VPC. We come back to the first tab here, and now if we refresh, we will now see that lab group, that target group that we just created. So I hope this makes sense. Like I said, this is a little bit different than what was outlined in the actual lab documentation, but you just have to create this lab group before you can continue on and complete this. So now that we've done that, we can go ahead and create the load balancer. And if we view the load balancer, we see that it is currently in a provisioning state. Okay, and now with that, we can move on to task 3. So we're going to create a launch configuration and an auto scaling group. So we're still in EC2 services. We're going to scroll down way to the bottom here under auto scaling. We see launch configurations. We'll go ahead and create a launch config, and we'll call this lab config. Of course, we want to select the AMI that we created earlier in the lab. So web server AMI. For the instance type, the lab recommends, it says T3 micro, but then it goes on to say if you're in the US East 1 region, which I currently am, and I suspect you probably will be as well, then we'll select a T2 micro. So we'll click this here. You can go ahead and search just for T2. Press enter, and then you'll see a T2 micro here. Okay, and now we want to be able to monitor this through CloudWatch. So we want to enable EC2 instance detailed monitoring with CloudWatch. And let's see, we want to go down here to security groups. Of course, we want to select an existing, and we're going to select that web security group again. For key pair, we'll leave this on choose an existing key pair, and then go ahead and choose the VOC key. We're actually not going to be using the key pair at all in this lab, but you can go ahead and select that. Okay, and then we're going to create launch configuration. You can see that that is created there. Now we want to create an auto scaling group from this configuration. So we're going to hit the check mark here. We're going to go to actions and then create auto scaling group. Okay, so we'll give this a name. We'll call it lab auto scaling group. You can see it's auto-selected that lab config that we just created. Go ahead and press next. Here, very important as always, we want to make sure that we're working with the correct VPC. So we'll select lab VPC. And now for subnets, now keep in mind, this is where we're going to be auto scaling our EC2 instances, our web servers that are pulling from that AMI that we created. So remember I mentioned earlier, this all you want to happen in the private subnets. So here we'll select private subnet 1 and private subnet 2. And you can verify that they are both selected there. Okay, we'll press next. Now, load balancing. Remember, we just created a load balancer, so we'll select attach an existing. And we could select our lab group here. And if we scroll down a bit, we once again want to enable some additional CloudWatch metrics collection. So we'll select this under monitoring here. Press next. So this is essentially what will trigger, when, for example, you'll see as we're about to set here, if CPU usage hits a certain amount, like 60%, for example. So it will automatically start provisioning, and eventually, as the lab specifies, we'll set a desired capacity of 2, minimum of 2, maximum of 6. So it could eventually provision up to 6 additional instances. So if we scroll down to scaling policies, we'll target tracking scaling policy. We'll give this a name of lab scaling policy. And like I was just mentioning, so we'll look for average CPU utilization. If it hits the 60% mark, then that's what's going to kind of trigger this, right? And it looks like everything else we can leave. So we'll click next. We're not going to add a notification, but this is very useful if you want to receive a notification when that auto scaling group is triggered. You could set a notification here through SNS, so that can come through like an email, for example. And for tags, let's go ahead and add a tag. We'll give it a name and lab instance. And you can see here, tag new instances. So this is going to add this tag whenever a new instance is provisioned in this auto scaling group. Okay, this is just a review of all the settings that we just made. And we'll go ahead and create that auto scaling group. All right, so we've created that. You can see that the status is currently updating capacity. So we'll give it a moment. It takes just a couple minutes. I'm going to go ahead and pause the video. And then once this is finished, we're going to see how it will have created already 2 new instances. All right, so I just went ahead and did a refresh. You can see that the auto scaling group is complete. So if we go back to instances here, we now see that there are 2 new lab instances created. Because remember, we set a minimum of 2, right? So now anything trying to reach that web server is going to come through the load balancer and balance between these currently 3 machines. So let's go ahead and verify that this is working. So we see these 2 instances here. Now let's take a look at target groups. And if we click on our lab group, we see both of the lab instances here. We can see that they're both healthy. So this will constantly be doing those health checks, right? So if an instance is not healthy, then the lab group or the Elastic Load Balancer knows not to send to that instance, right? Now let's take a look. We could load directly via the load balancer. So if we click on load balancers here and scroll down here and copy the DNS name, and let's go ahead and open up a new tab, copy and paste that. you can see this actually brings us right into our application, albeit it's very simple. All it's doing is just displaying some metadata about the instance. It looks like it links to an RDS database. But like I said, pretty simple, pretty straightforward. But as you can see, we're actually going directly to the Elastic Load Balancer, and it decides which instance to use to load this web server. Or I should say that this application, right? So let's go ahead and test this out. So let's take a look at CloudWatch. And we're essentially moving on to task 5 of the lab here now. So we'll go to CloudWatch and let's take a look at the alarms that we have for this. So under alarms, we could just click all alarms. You can see we have 2 here. So this one particularly, this is where we set the CPU utilization if it reaches above 60 for 3 data points within 3 minutes. So this is where it's going to trigger an alarm, and that would actually trigger, the auto scaling group. So if we return to this tab here where we have our application loaded, they have this handy load test that it's actually going to create some CPU usage on this machine. So we could actually see this happen. We could see these new instances being provisioned. So go ahead and click load test and just leave this tab open, because what it's going to do, you see here, it's going to auto refresh. It's generating a CPU load basically on this machine and other machines. So now we'll let this go for, usually it takes like 4 or 5 minutes, but eventually, and we can click into here too, into the actual alert here, or the alarm, I should say, you'll notice the CPU usage going up and up and up. So feel free to keep an eye on this in the next few minutes yourself. We'll eventually get to an alarm status, and then we'll take a look at our EC2 instances and see new ones being provisioned for us. So I'm going to go ahead and pause, but like I said, feel free to keep refreshing so you can kind of see the CloudWatch metrics changing as CPU usage starts to peak. All right, so I've gone ahead and refreshed. You could see here how the CPU is just completely spiked right now, and that is because of this load test that we have running. So you could even see how if you close out this tab and then continue to monitor, this will likely drop back down. But before you let that happen, let's go into EC2. And as you might probably guess, when we look in instances here, we have additional lab instances being provisioned for us. So potentially, see right now, these 2 other ones are being provisioned. They're initializing. So if you keep refreshing, I definitely welcome you to keep an eye on this. And if you had kept that load test going for long enough, it would have probably eventually provisioned an additional 2 more, up to that maximum of 6, right? Because it's still registering like, hey, CPU usage is still at 100%. We need to keep adding more. So essentially this verifies that everything was set up correctly. Like I said, feel free to keep refreshing, kind of keep an eye on this to just get that understanding of how this happens. But essentially this concludes the lab. It does give a task 6, which is just to terminate this web server. So just a reminder, if you ever want to terminate, you just click the instance itself, come to instance state, and then terminate instance. So we'll go ahead and terminate that. And you can see that that was successfully terminated. So it's currently in a shutting down state, and then will eventually be completely terminated. Okay, great. Well, that ends this lab. I hope you enjoyed, and I will see you in the next one.